Hi, in this video we're going to be looking at functions, and we're focusing on the November 2023 NSC final paper. So we're going to look at question 4, and we're going to start off by reading that question. So the question says, sketched below is the graph of f of x equal to 2 to the power x minus 4. Now that is an exponential graph, and the minus 4 actually represents your asymptote. So we can go to the asymptote and put down minus 4. They gave you a given domain, which is x an element running from minus 2 to 4. It goes on to say that a and b are respectively the y and x intercepts of f. So a is the y-intercept, means the x value is 0. B is the x-intercept, means the y value is 0. So we're going to start with question 4.1. And the question says, write down the equation of the asymptote of f. So the asymptote is y is equal to minus 4, which we've discussed. Remember, you cannot say minus 4, it is an equation. Determine the 4.2, determine the coordinates of b. Now, if we look at b, b is the x-intercept. And we know that for an x-intercept, the y value is 0. So we're going to go to the equation. And if we look at the top, the equation reads f of x is equal to 2 to the power x minus 4. So what we're going to do there, I'm going to delete that minus 4. We're going to go to that equation, and we're going to let the y value be 0. And that will give us 0 is equal to 2 to the power x minus 4. And I'm going to solve for this. I'm going to take my minus 4 to my left-hand side. Makes it a plus 4. Make my bases the same. 4 can be written as 2 squared. Bases are the same, therefore x would be equal to 2. And then I can go to b and put down 2. And the coordinates of b would now be 2, 0 in coordinate form. The next question, 4.3, says, determine the equation of k, a straight line passing through a and b. Now, if we actually look at the graph, so we have a straight line that is passing through a and b. Now, we all know that the equation of a straight line is y equal to mx plus c. So there's our equation, y equal to mx plus c. So we have point B, which in coordinate form is, that gives us 2, 0. Now A is sitting, or the y-intercept of both the straight line and the exponential equation. So to find a y-intercept, we'll let x to be 0. So what I'm going to do is quickly find that y-intercept, and the equation is y is equal to, and I'm going to the exponential equation, 2 to the power 0 minus 4, and that actually gives me a negative 3. So my y-intercept, which is point A, is actually 0 minus 3, okay, which I can also put on the graph. Now, remember, we want to find the gradient m, and we want to find, or we found the y-intercept. So we can quickly, whichever way we want to do this, we know y is equal to mx, and the c value is minus 3. So we can sub point B. If you sub B, or you could use the gradient formula as you have 2 points. So I'm going to go the easy way, subbing point B into this equation. y is 0, m, we don't know, we want to find m, x is 2 minus 3, and that gives me 2m to be equal to 3. Dividing both sides by 2, that gives me m to be 3.5. And then we can say that y will be equal to mx, so that's 3 over 2x plus c, and the c value is negative 3. And that is what our k of x equation would be. 3 over 2x minus 3. Okay, carrying on to some little higher level questions. You'll notice the next question is to find the vertical distance. Now, vertical means a straight line distance between k. Now, k is the straight line. Remember, k is our straight line. Between k and f. So it's between the straight line and the exponential at a point x equal to 1. Just to get a picture of what they're trying to tell us to do, sorry, b is the point plus 2. So at x equal to 1, they want to find the vertical distance between both. And to find a vertical distance, all we have to do is subtract the y values. So remember what I'm saying, to find the vertical distance, we're going to subtract the y values at x equal to 1. So if we look at the f graph, we need to find out, in the f graph, we're going to sub in 1 into the f graph to find out what the y value is. So it's 2 to the power 1 minus 4, and that gives us negative 2. And then in the k graph, which we found in the previous question, and I just want to remind you, k of x is equal to 3 over 2x minus 3. So if we substitute 1 into that equation, we would get 3 over 2 into 1 minus 3. And that's 1.5 minus 3, which actually will give you 1.5 units. Okay, so the y value there would be minus 3 over 2, you can use your calculator, or 1.5. So now, to find out the distance, and we're looking at a vertical distance, so all we have to do is subtract the absolute value of those y values, and we are saying that we're going to take minus 2, which represents 2 units, actually it's negative 2, so if we go to the graph just to get an understanding, you notice that the straight line is on top. Okay, so we're going to take, my mistake on that, we're going to take minus 1.5 minus minus 2, and that should give you a vertical difference of half. And there we have it, half units. Okay, we're going to go on to the next question. Okay, so the next question is saying write down the equation of g given that g of x is equal to f of x plus 4. So all we got to do is take the g of x, and where we got f of x, replace it with this equation, which is 2 to the power x minus 4, and then they're telling us to add a 4 to that. And that gives us g of x is equal to 2 to the power x, as minus 4 plus 4 equals 0. Okay, so in the last question, I just want to write that down. We found g of x, which was equal to 2 to the power x. Now, what I've done is given you an idea of what this g of x would be looking like if we actually had to draw the g of x. Because it's a restricted domain, we have to look at the graph, and I'm going to redraw that very quickly for you. We're actually looking at, because the domain is restricted, so we're going to go to minus 2, and if we substitute minus 2 in here, for y, we would get 1/4. So the G graph is starting at 1/4 for your y value, and the last x value we're substituting there is going till 4. So if we substitute 4, we would get 16, and that'll take us to the point called 16, and we're looking at a G graph looking something like that. Now that is important for the next question, because the question in 4.6 is saying write down the domain of G to the minus 1. So the domain of G to the minus 1 is equal to the range of G. So if we look at the range of G, we have y is the element, and as you can see the graph, from 1/4 to 16, and that's including. Right, so remember what I said, the inverse, you swap x and y, and you swap your range and your domain. So your domain for G to the minus 1, which is the inverse of G, is equal to the range of G, which will be x is an element, and the range is 1/4 to 16 for G. That becomes the domain. We go to the last question, and the last question is dealing with inverse as well. And I'm going to quickly change my color. So the question says write down the equation of the inverse. Now we know the rules for inverse. The equation of G is G of x is equal to 2 to the power x. Step 1 in an inverse will be to swap x and y. So we have y is equal to 2 to the x. We now make it x is equal to 2 to the power y. And then we introduce a log as we are solving for an exponent. And then y is equal to log x base 2. But remember that this graph has a restriction in terms of its domain. So we need to bring that down and stipulate that x is an element from 1/4 to 16. Thank you.